Today's chapter is Structure of Atom, class 11th. The topic is electromagnetic radiation. It is the energy emitted from any source in which electric and magnetic fields oscillate perpendicular to each other and traveling with the velocity of light. And these radiations don't need medium to travel. Actually, these radiations are produced by the oscillating charged particle electron and with which electric and magnetic fields are associated. For example, radiations produced in microwave, radiations which reach from sun to earth, right? And radio waves, UV waves, gamma waves. So these all waves are electromagnetic radiations because these are produced by an oscillating charged particle electron. And these radiations don't need medium to travel. It can travel in vacuum, right? These are different from water waves and sound waves which need medium to travel. Now the next comes characteristics of waves. ये आपने 9th क्लास में स्टडी किया हुआ है. What is lambda? It is wavelength. जो crust and trough के बीच का distance क्या कहलाता है? Lambda. This is crust and this is trough. And then frequency. Frequency is number of waves in 1 second, 1 by t. Then comes amplitude. Amplitude आपको मालूम है कि this is the maximum displacement upward or downward. This is called amplitude, the height of crest or depth of trough. Then comes wave number. Wave number is number of waves per unit length. So it is nu is equal to 1 by lambda कि एक यूनिट लेंथ में कितने नंबर ऑफ वेव्स प्रोड्यूस हो रही हैं. And per centimeter or per meter, it's a unit. Then velocity is c is equal to nu lambda, that you know. Now comes electromagnetic radiations. Examples of electromagnetic radiations. These are cosmic rays, gamma rays, X-rays, UV rays, Vibgyor, which is the light rays, IR, microwaves, radio waves. Right? This Vibgyor is a visible light. And so these rays are here, it is written in the increasing order of lambda. So when lambda increases, nu decreases because nu and lambda are inversely proportional to each other, and when nu decreases, energy decreases. So ये चीज़ आप ध्यान रखो, if lambda is more, then energy will be less or frequency will be less. Clear? Now comes another topic, photon. What is photon? Photon is a particle of light energy. If we consider that energy in the form of particles, then one particle of light energy is called photon. Now, what is Planck's quantum theory? Planck's quantum theory is the energy emitted or absorbed by a source is discontinuous in the form of small packets of energy called quantum, and quantum of light is called photon. So Planck's quantum theory, what he told, that light energy, जो energy है, that is in the form of packets of energy, and each packet of energy is called quantum or photon. So this is Planck's quantum theory, and he said E is directly proportional to nu, and or E is equal to h nu, where h is Planck's constant and Planck's constant is given. This is the Planck's constant value, 6.624 into 10 to the power minus 34 joules second. Now, if we take number of photons, then E is equal to nh nu, right? Next is photoelectric effect. What is photoelectric effect? The phenomena of ejection of electron from metal surface when a light of suitable frequency falls on metal surface. जब भी किसी मेटल सरफेस पर हम कोई लाइट उस पर फॉल होती है एंड विद द मिनिमम फ्रीक्वेंसी कि उसमें से इलेक्ट्रॉन्स इजेक्ट हो जाएं, निकल जाएं, that is called photoelectric. That phenomena is called photoelectric effect. And suppose here we have seen E is equal to h nu, but जो minimum frequency की if light incident on the metal surface when वहाँ उसमें से इलेक्ट्रॉन का इजेक्ट हो जाए, अगर इलेक्ट्रॉन इजेक्ट हो जाता है दैट मिनिमम फ्रीक्वेंसी पे, देन E that is called E naught is equal to h nu naught. That is called the work function of matter. Beta that E becomes E naught because here we take nu naught. Nu naught means of that minimum frequency जिस पर मेटल में से इलेक्ट्रॉन बाहर निकल जाए, इजेक्ट हो जाए, और उसके बाद अगर उससे ज़्यादा एनर्जी उस पर इंसिडेंट होती है देन दैट इज कॉल्ड E इज इक्वल टू एच न्यू, एंड इन दोनों का डिफरेंस उस इलेक्ट्रॉन को काइनेटिक एनर्जी देता है एंड दैट इज इक्वल टू हाफ mv स्क्वायर. फर्स्ट इलेक्ट्रॉन इजेक्ट होता है एंड इफ इट हैज़ वेलोसिटी with which it is moving, it means it is having kinetic energy, then the difference between the two types of energy is called this is equal to half mv square, and this is the kinetic energy by which electron is emitted from metal surface, जिस एनर्जी से वो इलेक्ट्रॉन उसमें से एमिट होकर मूव होता है. राइट नाउ दिस इज कॉल्ड डी ब्रॉगली इक्वेशन. Next, de Broglie equation, all material particles in motion, all material particles exhibit wave-like properties. This de Broglie said that material particles exhibit wave-like properties, and for that lambda is equal to h upon mv or h upon p. So for microscopic particles, if m is very less, so lambda can be detected. For microscopic particles, m will be less, so its wavelength can be detected. But for macroscopic particles, m will be large, so lambda becomes less, which cannot be detected. So microscopic particles have dual nature, whereas macroscopic particles does not. So de Broglie proved by its formula that microscopic particles have wavelength, whereas macroscopic particles wavelength, their wavelength cannot be detected. Whereas all material particles, when they are moving, they exhibit wave-like properties. Clear? Now comes questions related to these topics जो बेटा हमने अभी समझे हैं. Calculate the number of photons emitted in 10 hours by a 60-watt sodium lamp emitting radiation of wavelength 6000 Armstrong. हमें कैलकुलेट करना है नंबर ऑफ फोटॉन्स. सो पहले क्या है, we'll see given power is given, it is equal to 60 watt, lambda is given 6000 Armstrong, इसको हमने मीटर में लिख लिया, it is 10⁻⁻7 meter. T is given 10 hours, then it is converted into seconds, 36,000 seconds, 3600 से multiply कर दो. Now calculate the energy of one photon. Energy of one photon आपने अभी देखा is equal to h nu, h c upon lambda, because हमें lambda दिया हुआ है, तो यहाँ से आप E कैलकुलेट कर लेंगे. राइट, C की वैल्यू आपको मालूम है 3 × 10⁸. नाउ टोटल एनर्जी एमिटेड क्या है फॉर्मूला, Q इज इक्वल टू P इंटू टी. P is given, T, and this time is also given. From here we calculate Q, total energy. So number of photons क्या हो जाएगा? Number of photons will be Q upon E. इसको डिवाइड कर देंगे, we get the answer, right? So इसमें हमने पहले क्या करना है, टोटल 1 फोटोन एनर्जी कैलकुलेट करनी है, टोटल एनर्जी कैलकुलेट करनी है, और दोनों को डिवाइड करके विल गेट द आंसर. क्लियर? नाउ कम्स नेक्स्ट क्वेश्चन. Which one has higher energy, a photon of visible light with wavelength this or photon of visible light with wavelength? दो wavelength दे रखी हैं, उनमें पूछा है which will have higher energy. So बेटा इसमें कैलकुलेट करने की ज़रूरत नहीं है. इसमें आप देखिए E is inversely proportional to lambda, right? So if lambda is more, E will be less. If it is less, E will be more. So from here we find out that with the less wavelength, 4000 Armstrong, it will have higher energy. Now the next question, which has more energy, light radiation of wavelength, whether this of lambda, एक लैम्डा वैल्यू दे रखी है एंड द फ्रीक्वेंसी दे रखा है. तो अब इसमें पूछा है कि किसकी एनर्जी ज़्यादा होगी. तो इसमें हम फॉर्मूला लगाएंगे, बहुत सिंपल है, E इज इक्वल टू एच न्यू. इसमें एक को में हम इस लैम्डा का फॉर्मूला लगा के कैलकुलेट कर लेते हैं, राइट? एंड इन अनदर E इज इक्वल टू एच न्यू डायरेक्ट लगा के कैलकुलेट कर लेंगे, एंड which has more value you can find out. So light radiation of wavelength this has more energy, right? So in this way all these questions can be easily done. आपको जो टॉपिक्स कराए हैं बेटा उस पर जो फॉर्मूले हैं उन पर बेस्ड क्वेश्चन इस टाइप के आते हैं. एंड इन द नेक्स्ट वीडियो मैं स्ट्रक्चर ऑफ एटम से डिफरेंट टॉपिक लेकर उससे डिफरेंट क्वेश्चन से आई विल एक्सप्लेन दैट. ओके.